Hello everyone. Today we are going to discuss the solution of question same GCD which came in educational round 81, and it's a very good question on maths tag, and it involves two famous theorem, and if you can figure it out yourself it's good, but if not, look out to the solution and you will get to learn two very good theorem which you can use in your future solution, which involves some math stuff or the stuff which involves around GCD. So here is the question. You are given two integer a and b. Calculate the number of integer x such that the GCD of a comma b is same as GCD of a plus x comma b, and the constraint of x is from 0 to m. Okay, you all know what GCD is, right? So need not to read that. And the input is like we are given test case, and then just two integer a and b. And what we have to output is count of integer number of integer x which are from 0 to m and satisfy that equation. Okay, so let me straight away go to whiteboard and then better explain you over there what this question is all about. Like we are given a and b, and the GCD of a and b is equal to a plus x comma b. So the range of a plus x comma b we don't know. We just know the range of b, which is 0 to m, 0 to b. Don't get confused with a, b and m. I have to write a and m. The GCD of a and m is equal to a plus x comma m, and we don't know the range of that, so we know just range of x, which is 0 to m, and we have to find number of x which satisfy that. Okay, so if you figure it out, if you can, you just pause the video and thought of a solution which comes to your mind. Most probably you will get something sort of factor type and try to iterate over all the factors which is right, like the GCD is constant for these two. Let's assume it is alpha. So these two number must have factor alpha common in them, and then a plus x, and we have to add x in such a way that alpha factor is intact in it and no other factors which present in m comes in it. Like if let assume m is composed of alpha into p. P is product of all the other factors which haven't come under GCD. And what I made a plus x is, now a earlier a and m, the GCD is alpha. Okay, fine with it. Means a is having factor alpha in it, and then if I add a plus x, I sort of included some factors which are there in P, so my GCD will change. Or if I add a plus in such a way that I eliminated some factor from alpha, so again the GCD will become less, and again GCD will change. So what I want is, I want a plus x in such a way that in that number the factor alpha will be there intact, and no other factor will added which is also included in m. I hope you are getting the point. So you sort of thought of that way, and you will thought of writing some solution, something. Just try it by yourself first, and then if you couldn't figure it out yourself, then try to watch out the rest of the videos. So you can pause the video over there and try to implement it by yourself. Okay, so now let's start with the solution part. Let me see, the recording is going well. Yeah, it is. See, first of all, I will use, or in that question you should think of Euclid theorem. What it does is, it says, let me wait in it. It says Euclid theorem. Euclid, don't go with the spelling. I know it's wrong. Theorem state that if A is greater than equal to B and GCD of A comma B is X, then GCD of A minus B comma B is also Bx. So what you can do is you can keep on eliminating, keep on subtracting m from A up till the point A, like A minus xm is less than m. Like you go on, like first of all, if A is greater than equal to m, you can subtract A minus m. Now again, if A minus m is greater than equal to m, you then again can subtract A, so now it become A minus 2m, and so on. You can go on subtracting m from this first term until the point this thing doesn't hold. So eventually what we will get is, eventually eventually we will get A equal to A modulo m, right? Try to visualize it, like you will get A equal to A modulo m after repeat, after keep on subtracting m from it. Okay, so now our original equations turns out to be like, so this thing is Euclid theorem. I should place it over there or somewhat there, yeah. And this thing is what we are getting after applying the Euclid theorem, right? And I should erase this thing. Yeah. Now what we are left with? We are left with A. Our first term is A, like A plus x comma m turns out to be A plus x modulo m. And if we are doing modulo with m, we are sure that this number is from range 0 to m minus 1. And here is the trick. As you got this thing, like now you want is GCD of some number to some other number equals to alpha. Now let's get rid of this alpha. So I just go on dividing this alpha to both the number, like this first term and the second term also. Then what I am left with, a number which range from 0 to m minus 1 by alpha comma b by alpha, sorry, m by alpha GCD equal to 1. So I am left with this thing. This one is 0 and this is, I am subtracting. So let erase everything else, as our final thing goes down to that. Now we want number of x which satisfy that thing, like 0 to m minus 1 I have written, but it is actually A plus x modulo m, right? So I have to find total number of x which satisfy this equation. Now Here we can use a very famous theorem, which you can also remember in for the future problems. Like if you have encountered some problem like GCD of a comma b equal to 1, right? And GCD of a comma b equal to 1, and you need to find number of a which satisfy the equation, and the range of a is from uh, 1 to b. Then you can simply use Euler Totient theorem. It's simple formula to calculate total number of b which satisfied that particular equation. Like we know b, we know m is given, and alpha we can find GCD of a comma m. So we know this number. What we need to find is this thing, like count of number which satisfy that equation. So we can straight away use that Euler Totient function. Euler Totient function says that, I just go on open the Geek for Geek site for the Euler Totient function, and then from there I will explain you. See, Euler Totient function for an input n is count of number in 1 to n. See, we previously did Euclid theorem to make sure that our first number is from 1 to n, and which we have already done it. So we can use Euler Totient function over there. It's count of number in 1 to n that are relatively co-prime. And what does relatively co-prime means? Simply their GCD is 1. Okay, so you can straight away use that theorem, and we need not to prove it. We just go on and use that thing, like phi of n equal to n into pi of 1 minus 1 by p, and p is all the factors of n. So you can calculate factors of n in square root of n time, and then go on calculating the value using that formula. But this involves quite a lot of multiplication, which you can do in basic algebra. But while dealing with C++ language, there might be some round off issue or something. So we will do by some another approach, like you can also try doing this thing, but there might be some round off issue, like you can get answer which is one less than actual answer or one greater than actual answer. So to avoid those floating point calculation in above method, we will use some another method. And let me explain you how we will calculate this thing in bit detail in whiteboard. Okay, so I guess you are comfortable up to that point, like how we are calculating. Yeah, the recording is going well, I guess. See, we need to calculate total number of A such that GCD of A and B is 1, and we know that A is from 1 to B. You can ask one question is, in our question we prove that our first term is from range 0 to b minus 1, but in theorem it is given that the range should be 1 to b. So how it's like how we are dealing with it? So let me tell you straight away, let me tell you now only. See, if you take GCD of any number with 0, it's like GCD of 0 comma n, it will give you n. And if you again take GCD of n comma n, it again give you n. So you can sort of replace 0 with n over there, and so that if our original equation fits in the theorem equation, like which is required in the theorem. It's just to fit in that, nothing like we simply exchange 0 with n. Okay, fine. So what we want is count number of a such that GCD will be 1. See, if you do the prime factorization of b, you will get some prime number. Let's assume it's p1, p2, and sorry, p3 and p2. Okay, fine. P1, P2, P3. And if A is any of these prime factors, then surely the GCD won't be 1. It will be P1. If like A is P1, then GCD obviously be the P1. If A is P2, then GCD can be P2, and so on for all the factors. Or if A is any of the multiple of P1, then also GCD cannot be 1. So what we want is, we want, first of all we will initialize our answer to be B, means we are taking all the element from 1 to B, and now we will go on subtracting all those which are not giving GCD 1. And I just now said the number which are multiple of some prime factors of B is surely not going to give you GCD 1. So we have to eliminate all the multiples of P1, P2, and then P3 from that, from our answer. So mm, we just have to eliminate B by P1 and keep on doing for all the other factors. So I guess, and the answer which we will get is our final answer, which we want in, which is asked in the question. So I guess that's it with the explanation part, and we can now go ahead and code it this thing in our VS Code, I guess. So let me see what's the input. So we are given with the test case, so I'm commenting out this, and we are giving a comma m, scene a, scene m. Let's take GCD of these two numbers first of all, a comma m, and I go on dividing m by GCD of these. Now what we have to do is, we have to do this thing, which I have told you. Like we can straight away use Euler Totient function. So I have to find all the factors of this m by alpha. If m modulo I equal to 0, what we can do is, first of all let's initialize our answer to be, and then we can subtract answer minus equal to answer by I, right? And we can eliminate, like once we get rid through the all the multiples of 2, then we can simply divide this factor up to, like so that we cannot eliminate it twice. We just get rid of this factor once and for all. So what we have to do is m modulo I equal to 0, then m by equal to I, and in final if m is greater than 1, like we are left with some factor, then again we have to subtract it, answer by m, and straight away see out our answer. I guess that's it with our code. Let's run it. Hopefully, it will give the correct output, which is 6199966. Yeah, it is giving us the correct output. Let's submit our code. Yeah, it got accepted. So I guess that's it with that question. So if you like the solution, do subscribe the channel and stay tuned for the further videos. Like I am going to do the screencast of further future contest, and also giving you the editorial, video editorial for many of the question which I like or which I recently solved. So thank you so much. Bye bye.